All right. Hello, everyone, and welcome to day 3 of Advent of Code 2022 in Kotlin. Nice of you to tune in once again to join us, this time on a weekend. How crazy is that? But Advent of Code doesn't stop just because the work week's over, which is great. I'm always looking for excuses to get up at 5:45 in the morning on a Saturday. But honestly, now that I have a purpose, that there's a reason why I need to get up, it's actually not that bad. It works pretty well. Also, a little update, I'm feeling a little less sleepy than yesterday. Sleep cycle is slowly adjusting. I'm sure a couple of other people who have forcefully twisted things are in the same boat. So yeah, if you're tuned in, make sure you say hello, and also, just like last time, maybe give us a little bit of an evaluation how hard the problem was for day 3. Scale from 1 to 5, not very hard, however you want to describe it. And just so that we kind of get a bit of an idea. Now for me, I'll do a little bit of a spoiler. This was kind of a lucky one because a talk that I gave recently at a conference actually tackled a couple of the language features that I used for solving this one. So, yeah. Let's have a brief look here. I'm gonna go on my second screen. Found it really easy today. Easy. Look at that. Wonderful. Sounds like, yeah, people didn't have it too hard. People had a good time. But it's nice, right? It's on a weekend, so it's also nice to have more of the day, have a little bit of sunlight, go outside. I went outside before this very event, and I was worried that my fingers would still kind of be stiff because it's so cold outside and I forgot my gloves. But fortunately now with a cup of tea, they're slowly warming up again. Now, all right. As for housekeeping, fortunately, there's not that much to discuss today. You've of course all already known our wonderful blog post, which pretty much links you to everything you can find alongside with the stuff in the description on YouTube and wherever you find information on Twitch. If you're looking at the restreamed version, I don't really know. But the main point is that we've now managed to fill all 3 leaderboards, which means there's a 4th leaderboard which you can join. If you have not joined one of the previous ones yet. So make sure you are in one of them, but make sure you're not in more than one of them so that other people can also join them. I'm the only one who gets to join all of them because I have to determine who wins at the very end. Now, luckily, okay, first of all, we have a bit of a question. First one's a spoiler, so I'm not going to read that one. The second one is the Slack registration for the Slack channel supposed to send an email? So that's in reference to our Slack chats Kotlin Lang Advent of Code channel, where I said yesterday that you can click join the conversation for the sign up. And the answer for that is yes. This should send you a link. And if that doesn't work for some reason, you can either try again. You can write me a Twitter DM. My Twitter handle is down there. You can write me an email. My email is sebastian@jetbrains.com. You can do that. I'm gonna figure it out. Or you can actually just contact Alina, which is the email address that's actually linked here. Yeah, do that. You know what? Do that instead. It's gonna be much easier if it's not received within 48 hours. Okay, great. So with that, I'm excited to introduce my guest for the day because, of course, we're not solving things alone. Today, I have Maya Huretepas, who's a GDE for Android, a longtime Android developer, and a big fan of Kotlin. Welcome to the stream, Maya. How are you?
I'm great, thanks. I'm very happy to be here.
Yeah, it's good to have you. Thanks especially for making time on a Saturday.
Yeah, it was fun. I was a bit worried about Saturdays because I know in Advent of Code in the past, sometimes the Saturday puzzles are a bit tense. But I was quite relieved that I could just jump through this puzzle this morning and then still have the rest of the day and look forward to doing the stream tonight.
Yeah, it's always a double-edged sword. I feel like it's either the Advent of Code gods want us to spend our Saturday, or they want to give us a little gift, and let us enjoy the outside for a bit.
Yeah, I see someone in comments is saying that my volume is high. Is it something you can control, Seb, or should I be doing something on my side?
I'm sure I'm gonna get a comment from production in just a second, and then we'll address that. But I think.
Okay.
Yeah, I think you're fine at this point.
Okay, great.
Yeah, I hope so. Otherwise, I'll just make myself louder, and it's just gonna turn to a shouting match. It's gonna be fun.
No shouting match today. Just cooperation, right?
Yeah, of course. So, before we dive in, just for some context, you said also pre-stream when we were talking that you're like extremely into Kotlin, and that's kind of one of the languages you enjoy the most. You want to just briefly kind of elaborate a little bit on maybe what it is, or how you even got to falling in love with Kotlin?
Yeah, I guess I knew it was Kotlin when I had to code Java again and I couldn't remember any of the syntax. I'm sure other people have had that experience as well. I've been coding a long time and I've tried various different coding paradigms for different problems. Everything from, I don't know, basic a long time ago, imperative coding, and then object-oriented coding years and years and years in Java with all its pomp, ceremony, and boilerplate, and then recently Kotlin. And I think it's much less code to read, so things go quicker. And it feels great. And also, specifically for Advent of Code, I like to get myself to try on a different coding paradigm or a different coding style, depending on what the problem is. Like day 2, I just had objects and enums everywhere, not very efficient, but it was like pure object oriented. And then for this morning, I said, let me try something else. And I don't need to crack open the Haskell compiler or interpreter or whatever they use. I can still use Kotlin and I can just pick the style that suits my mood or my problem of the day. And I think that's like one of the really great things about Kotlin, that it's so expressive in the different styles.
Yeah. I definitely agree. It's nice having a toolbox that's just kind of there for you whenever, with a really wide variety of tools that covers everything, and where if you see a problem, you can approach it in different ways, and you can pick the one that works the best for you, and that also works the best for the problem.
Yeah, and also like if you get a problem where maybe the language isn't exactly right and you think you need to write your own domain-specific DSL type of thing, then that's possible too.
Yeah. I wonder if the Advent of Code puzzles are going to get to the point where at least my refactored solution is going to have a DSL. I guess we saw a little bit of that yesterday, with overwriting the symbols or introducing infix functions to make things even more readable. But I'm curious to see if we're going to go any further with that.
I have to confess, I also had an infix function yesterday, and quite a few extension functions on string.
It's a good instinct. I mean, I was kind of in the same boat. I did feel a little silly when I got shown one of the answers, which was just, oh yeah, you can just write out all the combinations. There's just 9 of them, so it's like, oh
yeah,
right, okay.
Yeah, and I'm not in it for the coding golf, right? I don't want to use the least amount of characters.
Sure.
I'm actually in it to try different approaches.
Oh yeah. So let's kind of see how today's problem looked like, and I had so much fun doing a a dramatic reading last time that I'm gonna do another one. Unless you want to take over like really bad?
No.
Very
you can
good.
Read.
Exactly. So then I shall do that. And we begin our story for the day. Day 3. Rucksack reorganization. One elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item per rucksack. The elves have made a list of all of the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is A and lowercase a and capital A refer to different types of items. The list of items for each rucksack is given as characters, all on a single line. A given rucksack always has the same number of items in each of its 2 compartments, so the first half of the characters represents items in the first compartment, while the second half of the characters represent items in the second compartment. For example, if we have the following list of contents, then we can split these up into the 2 compartments, and we will see that for this input string, if the first compartment is the first half of the string, the second compartment is the second half, the only letter that appears in both of them, or the only item type that appears in both the compartments, is the lowercase p. And then the same thing goes on for the other ones. To help prioritize item rearrangement, every item type can be converted to a priority. Lowercase item types, lowercase a through z, have priorities 1 through 26. Uppercase item types, capital A through z, have priorities 27 through 52. In the above example, the priority of the items that appear in both compartments is 16, 38, 42, 22, 20, and 19. The sum of these is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of these item types? All right, so Maya, what kind of problem do we have in front of us here? Walk us through this.
Yeah, so at my first reading, since we're dealing with strings here, I guessed we would need some string manipulation. So that was one of the things that I looked at. And for this particular problem, I wanted to get myself to do standard libraries and functional programming. So that was the toolbox that I reached for, and the pages that I had open next to me, the Kotlin Lang documentation for that I had next to me. And so the thing to notice here is that we've got the 2 compartments. I made an assumption from what they were saying in the text there, that they split down the middle. So what we want is we need to split the string, the first half of the string and the second half of the string, and then have some way to match up these characters to find which ones, where the duplicate is. Now, imperative style, you could have like a for loop chasing through it and find an intersection like that. But since standard libraries was my goal for this solution, I had to dig around and I found a really nice infix operator that you can apply to I think lists or sets. You can iterable. You need one of them needs to be an iterable, and then you can get an intersection of that. So my plan was to take these. So the algorithm for one rucksack, or the process for one rucksack, would be split it in the middle and get the intersection of the 2, and then you've got the letter. So that would end up in a list of the unique or the duplicate items across all the little rucksacks. But now you need to score them. So I think yesterday we had this trick where you were converting the letter into its ASCII number, which is really neat, except that in the ASCII table, the lowercases come first, and then the uppercases are after that. So it's not a straight conversion. I guess there's some some calculations that you can do to convert that. You could also use like a kind of a map to look up the character and like get its index. But I think the solution that I went for was just an F with an is uppercase.
Okay.
And then whatever calculations you need to get the score. So then you would just chase all of your single items through the converter to the score and then sum it.
Okay, so let's see what that looks like in code. Let me make sure I have the correct part open here. And we can take a look. Okay, so take us through this. Where should we start?
Well, you'll see this class has got some other annotations, but we'll get to those later.
That's right.
What we've got here is, of course, here at the input, it's reading the information in, the test data or your actual puzzle data. And this comes in as a list of strings. And so here, over here is where you take the input and then you call a map on it. So what that's going to do, it's going to take every single string. So each little backpack that comes in or each rucksack that comes in is going to be split. And so the way I split it was by saying, take a substring from the beginning to the middle. So this part here is a substring from the beginning to the middle. And I did the character array conversion over here because later I need it for the intersect.
Okay.
And then I made like a pair. So there were the two. This makes a pair and this is the second half. So there's the second. So this is the splitting of the rucksack into the two here, this part.
Okay.
So
yeah.
what
This essentially it creates one large pair with the two operator in the middle here, and then with the two rucksack substrings.
Yeah. So what's cool to see here is in the IDE you can actually see what's going to come out. There's a pair here. You can see. I don't know if you can see my cursor, but yes, you can see my cursor. So here you can actually see it's two character arrays for the two compartments, and it's in a pair, and there's a list. So then the next thing, now we've got things split. Now we have to find.
Actually, before we go on to that, just real quick, I wanted to also notice something here. So first of all, what I actually didn't realize was that you can have a substring with just a single argument. So because here you are using range syntax, right? This creates an integer range, whereas over here you're literally just saying create a substring with the second half of the string. I kind of didn't even think of that when I wrote mine. I just kind of was like, okay, it's the half plus one until the last index. So this is a nice little addition. Okay, sorry, didn't mean to interrupt.
No problem. Yeah, so that was just because I had the docs open next to me when I was doing this. And so this is really useful in Android Studio, the fact that you can actually see the type that comes out of this. Because these functional chain operators are sometimes a little bit difficult to step through, right? I mean, they're not so easy to put breakpoints in them, unless you know a trick that I don't know.
I'm not sure I do.
Okay.
My favorite. I'm a very much a print debugger as well. In cases like these, at least in this kind of context where I have well-known and small data sets. So I usually just sprinkle in a couple of also.
Yeah, so it would be also something like this. Like if you wanted to know what's happening here, you would put something like this.
Yeah, so just for kind of context, the also function is one of the scope functions that we have in Kotlin, which is used for doing side effects while passing things through in a call chain. Yeah.
And so I like doing it like this so that then later I can just go like this and then it goes away, right?
Yeah.
Okay, so I'll leave that in there so we can have a look at it later. So then, so we've got these two compartments coming through. And then I did a flat map here. I had a map first, but then the result of this, if you use a map, is like a nested thing. So the flat map just like spreads the answer into just one list, or I don't know what's the right word, collapses the answer or flattens the answer. Yeah, flattens the right word into a single list. So what we're doing over here is I'm destructuring the first and the second part of my pair over there. Yeah. And then I just call first intersect on the second. And so this intersect is an infix operator that will get the intersection between the two. but it needs the second one to be of type, let's see, it needs to be an iterable, which is why there's this toSet over here.
Mm-hmm. Okay.
And so you can see here, we're going to get a list of chars coming out at the end. Yeah?
Okay. So actually, the only thing that I'm thinking here is if you're doing this kind of conversion down there, you might not need these char array calls up here. I think if you get rid of this one and this one, so one of them you can definitely get rid of. I guess you would have to make sure that this one is a set down here as well.
Okay.
So that was just something that appeared to me, because it saves you doing that twice.
Yes, absolutely. Okay, that's a really good optimization. Yeah.
Just a little detail, but yeah.
No, absolutely. So I think what happened was, I mean, I've not been back to this code and cleaned this up. I think I had them in a char array first, and then I realized I needed a set. But yes, it's better to have them both as sets at this point.
I think so. Yeah, but
cool.
This is on the IDE for not figuring out that a superfluous conversion is happening here, right?
Or if we had 100 million backpacks to sort, we'd find out when we benchmarked it, right?
Certainly, then we would find out the difference. That's for sure.
Okay, and so the last piece that we need is just to sum things. So we're getting the character of the characters that are duplicated in the two sections over here, and then we just need to convert it into a score and then sum it. Now this too long we don't really need, but in my template I work with longs, not with ints, and so that's just there because of the way that my template is defined.
I think that's how you know that you've done Advent of Code before. This is like the hallmark thing of one of the later days being like, your answer is too low. And it's like, oh, what could it be? And then you try to estimate it. Yeah, you try to estimate it in your head, and you're like, this is probably bigger than 2.1 billion, isn't it?
Absolutely.
Yeah, so good thinking. Actually, a good reminder for everyone and for myself as well here to make sure that when push comes to shove, make things longs.
Yeah, or sometimes I think I've even seen a place where I needed a big integer.
I don't remember that, but I absolutely buy it.
Okay, so this to score, I told you I just used an if. So my if is just like this here. It's just check if it's an uppercase, then get the ASCII code for A. This code minus A. Okay, so this gets the offset after A and then adds 27 to go. So actually this could be, I could see what this 27 could be. Maybe we could find a better sum for this. Now, this comment that I have in here, oh yes, okay, so the comment was in there just for me to check that this calculation over here was correct.
I also, by the way, I also had an off by one error on this one. So I just, it's like, right, it's 26 characters plus one character like down here. So it's like shifted by 26, I guess. Yeah. But I mean, apart from that, this seems pretty reasonable.
Yeah, so this was why this comment was in there, because I literally copied this from the test, from the question, just to make sure that I had the right thing here. Okay.
By the way, what I like about this on the one hand is that this is nice and expressive using the dot code. But I think, what does the code give you back? That gives you an integer back. So in this case, I think you can also just do the minus on the characters directly. So you can do this, and I think that works just as well. Which kind of looks a little bit more like what Marton did yesterday from a syntax perspective. Either works.
Run honestly, the test just to convince me.
Yep, sure. Let me see here. I'm not familiar with your template. Do you just do the?
You just go to day 3 test. I think you can run it.
Oh, you just have a separate file for that.
I just
Days.
run it. Run. Can I run?
I'm
not permitted to run.
Then I'll run. So it's this one. Okay.
Yeah. Something's wrong. Something's wrong.
See here.
I know. Oh wait, I need to fix this because I fixed this for that other thing. Wait, like that, and then we've got to go. Setup. Oh, it's not going to work. Sorry, we can't run the test. I did some hackery in the code because I wanted to benchmark stuff. It's not going to work.
That's perfectly fine. That's going to be the more interesting part anyway. But I think this should behave the same way, just as well. Okay. All right. Cool. I mean, but this kind of gives us a. I like that this is a very literal description of what you said in the beginning, which was, well, we want to have both sets, right? Or we want to interpret both parts as sets, and then we just want to see which is in both of them, which in like set theory or whatever is literally just the intersect. And we have the function here, so it all after parsing things, which kind of I would still say this part is parsing. It's a 2-liner, which is nice.
Yeah.
Okay.
So if I needed to like optimize, I guess, I mean, there are all sorts of things you can do to optimize, because these standard libraries potentially could, I'm sure you could write it in like for loops and things much quicker. If I were to rewrite it and not use standard libraries, then I might make like a bit field for each letter and then just add them to get the intersect. And then
that is also a clever idea. I like that as well, especially since they are, since they are just characters. So you're not gonna have
so like a
arbitrary
bit set,
length.
whatever. Mm-hmm. What is the thing in Kotlin you can use? There's a bit set, right? Isn't there a bit set? You'd have 26 bits.
I think on the JVM we have a bit set, yeah. That's also that's a cool approach that also I kind of honestly didn't think about. Would be a cool way to see how performant you can get it. I'm always the fan of the expressive ones using the built-in data structures, to be honest. Okay, so well, I would say that's part one checked off. So we're gonna do another quick dramatic reading, and after that we'll discuss your second part, and then I'll also quickly pull up my own solution so we can compare a little bit, even though they're pretty similar today. Okay, so as you finish identifying the misplaced items, the elves come up to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack, and at most 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, nobody wrote down which item corresponds to each group's badges. The only way to tell which item is the right one is by finding the one item that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first 3 rucksacks are the following, and then the second group's rucksacks are the next 3 lines. And in the first group, the only item that appears in all 3 rucksacks is the lowercase r. We can find this one here, here, and here. This must be their badges. In the second group, their badge item type must be Z or Z. Priorities for these items must still be found to organize the sticker attachment efforts. Here, they are 18R for the first group and 52Z for the second group. The sum of these is 70. Find the item type that corresponds to the badges of each 3 elf group. what is the sum of the priorities of these item types? Okay. So I'm not sure about you, but at least I kind of sighed of relief when I heard about this second part, because I was like, oh, this is kind of the same as the first part. We're still kind of just doing intersections, right?
Yeah. So I think one thing that sort of caught me in the beginning was I was thinking that maybe I could use some group bys and count characters. However, if you look at those strings carefully, you'll notice there are other items which are also occurring across the three elves. So you can't really do that. You have to do an intersection. So you have to find which ones are only in the three rucksacks. Yeah. And the other thing which was a relief when I read that is that they didn't change the way the scoring worked. So I could still use my old scoring method.
Yeah, which is quite elegant. I'm not sure about you, but at least for me, the first thing I did was I was like, okay, let's do a quick sanity check. Let's see how many items there are in the input list. And I was like 300. I was like, okay, that divides by 3, so I don't have to do any special case handling for any partial groups.
Yeah, or like the poor little one elf without friends right in the end, right?
Exactly, something like this. Okay, so how did you approach this?
Well, I didn't make the generic solution that could have been like for any number of, doesn't matter what size group it is. I just said, okay, we've only got 3 elves in a group and there isn't a pot 3, so I don't need to make the generic solution. So I used this nice chunked method, which you get, which if I just hover quickly, it's going to say splits this collection into a list of lists, each not exceeding the given size. So it's literally going to do the split exactly the way the elves are split. So that's like really easy to use. So of 3. And so again, you can see we're getting a list of lists of strings. So we're actually getting a list of elf groups with the little rucksacks inside each elf group. And so then I did a map across this. So I'm going through each of the groups. And then obviously when I have the group of rucksacks, I've got to find the item inside the 3 rucksacks that appears in each of the 3 rucksacks. And so what I'm doing here is I'm using the zip with next. Now, zip with next, you can use windowed as well, but I was using zip with next because I'm just comparing the first with the second and the middle one with the last one, which is what zip with next does. And then this is also, it's okay to do this for the solution because we've only got 3. Now, if I had 4, there might have been a problem with the first and the last one, potentially. There might have been some issue trying to find what's across them. You might have needed to find a different way to do it, but for our purposes, this works fine. And so this zip with next is going to give me a pair of 2 rucksacks, a list of pairs of the 2 rucksacks. So the next step from that is just to go like comparing the first and the second, and then the second and the third with each other, and then just use the same intersect as before. Now I'm thinking from what we did before, I could change this to 2 set, right?
You absolutely
We had that before. Yeah. And then it would be more similar to the one we had over here.
Yeah.
And potentially, I mean, you could also just extract this if you needed to extract it, but I think it's so short that I don't know if it's worth extracting into a little method on its own, because that would just mean another method call and another call stack. And so, yes. So that's at that point. So at the point here now, when we come out of here, we get a list of a set of characters. Which
that's
we
what
then
get down here as the shared items.
Yeah, as the shared items. So the shared items would appear then as a list. And so again, using flat map just to collapse things into one list. And so here I'm saying that this is the second intersect happening over here. So here was just the 2 ones and then the shared one. So it might be that there's more than one thing shared between the first and the second backpack. But now we need to see if we need to see between the shared ones, the one that's, yes. Let's see. How did this work again?
Which is your first two, and then I guess your last. I guess the
yeah. Yes, it's a mystery now to me. I'm reading my code and I don't understand my own code here. I did leave a comment here saying index is safe because we chunked by 3 and then did a zip next. Oh, yes. Oh, no, I know what it is. This is the share between the first and the middle one. And this is the share between the middle and the last one. So now we're just checking what's shared between those two.
Mm-hmm. Okay. And then at the end, we just kind of sum everything up again.
Yeah.
And kind of get our result. Okay. So someone mentioned in the chat here that they would use fold or reduce, which I guess would also be kind of elegant as one of the alternatives. So instead of doing a zip function, you would essentially take all the items in your input collection and you would iteratively intersect them individually. Now, the one solution that I'm seeing here in the chat, which is folding with an empty set as a start, that one's not gonna work, Jonathan, because when you start intersecting something with an empty set, you're gonna get an empty set real quick. You're not gonna get around that one, so that might not work. I'm just thinking. I guess we can try just looking very briefly at the alternative here, so that we can play this out. I've not done this implementation yet, so you're gonna have to bear with me. We could do a chunk of size 3, and then we reduce this, I think. Which we reduce to, let me see here. So this one needs, I always keep forgetting which one is I think it's the accumulator first and then the element second. They're both strings, not very helpful. Oh yeah, you can't do it with an actually, this one doesn't look that nice because you need to do some kind of conversion to sets beforehand. So let me just quickly see here. Gonna give this a quick try. I'm also gonna briefly put this in here so I don't have to constantly work in red code. Accumulate an element without parentheses. Thank you very much. Very good call. That's the difference between having 2 parameters or having 1 parameter that you can destructure immediately. Or if you're writing JavaScript, just like Luca said here. And then we would say accumulate intersect element. And I think this one, as its result, should give us the... Nah, I would have to turn each of these into character arrays first, because these are lists of... yeah, okay. You know what? We're this one's gonna stay homework for people. If you want to show us some solution for part 2, you can. See here, we got someone saying input chunk 3, sum off, and then with a reduce with an extra function. Okay, yeah. So we might look one of those up. But the general gist is you can probably do a reduced solution for this as well.
Yeah.
Just to kind of get arbitrary length, because then you can kind of do step-by-step things. I'll be very honest with you. I've been up for a little too long to just kind of whip that one out real quick.
So I see another thing in the I see another comment in the chat there. Someone was saying, can you go first, second, do an intersect and not do the zip with next?
Well, that's a great segue. Because now we can look at how I solved this problem, which is a solution that looks somewhat similar, but that addresses exactly this point. So, let's briefly switch over here. Unfortunately, this one's not in code with me, so you're gonna have to check out the StreamYard if you want to follow along.
No.
Yeah, I'm also just kind of reading the input first, and so the way that I determine the shared items is just like Maya did, except I was not clever enough to find out that there's an overload that allows me to just use a start index instead of having the last index function. Yeah, but I just create the sets of characters here as well. I do an intersect, and instead of let's have another quick look here of how you did this one in the end. I think you did the flat map. So instead of using a flat map, what I did was I just said, I know that this is always going to be just one element. So I can call the single function, which does the kind of unwrapping. So if we actually look at this one, if it loads, we'll see. Unfortunately, reader mode is very small. Returns the single element or throws an exception if the collection is empty. So that's just my way of turning this collection into an individual value. And yeah, from that, I also just need to generate the priority. The logic behind this one is exactly the same as Maya's. I just chose to use an extension property. So I had to define a get block on character, just because I thought that looked a little bit nicer. Apart from that, this is pretty much the same thing. And for part 2, I did pretty much the thing that I think people said in chat. I first chunked the input into chunks of size 3. And then, since I know that these chunks are always of size 3, I used a destructuring declaration. So I just split this into A, B, and C, which are the first 3 components. If you want to see even stronger abuse of or use, I should say, of component functions, you can go back and watch yesterday's stream with Martin, where he showed how he would implement this functionality manually. Yeah, but this just gives me the 3 elements, and then I just intersect them directly, use the single function, and do the same sum, which just kind of tries to reduce a couple of the function calls. And after seeing this, I thought to myself, I really don't like having all these conversions everywhere. So it would be nicer if instead I just had another overload for intersecting strings directly. So I wrote one, which is essentially just this exact code. It turns the first one into a set, the second one into a set, and then gives me the intersection. Which means now I can just write A intersect B intersect C. Actually, well, I'm pretty sure need to put these into parentheses. And still need to put this one into sets because I forgot to implement the second one, the second overload, which this one we can definitely do live, which is for an iterable, which is what we have on the left side. And so we have a set of characters intersect other string, and that one will just do this intersect other to set, and now we can write A intersect B intersect C. Just a little mistake. But yeah, we can do the same thing, of course. Now we can make this one up here a little nicer as well, because we could just use the strings directly. So let me just make these changes. Not sure why my keyboards. There we go. So it just kind of shrinks everything just a little bit. Now I remember also as well that you said beforehand, if you're introducing extra functions, you might be introducing extra call stacks and stuff. Now the beautiful thing is that in Kotlin, we can always mark a function as inline, which means that the compiler is actually gonna go and essentially copy this code wherever we invoke the function. So we get the added bonus of whatever syntax sugar we generate without any overhead. Now, realistically, on a modern JVM, inlining this is going to be trivial and might even be done at runtime just by whatever, whatever JIT compiler you have. But you can give the hint. Yeah. Mm-hmm.
Oh yeah, I was going to say hover over the hint, because usually it says something about, what was the message that it said there over the inline?
So the hint that it says is expected performance impact from inlining is insignificant. Inlining works best for functions with parameters of functional types. So of course, the main use case for inlining is when you have lambda functions where you don't want the function objects to have to be allocated and all these kind of things, and instead you just want the code copied wherever, because that saves you invocations. But I think that even in the Kotlin standard library, you will find a bunch of these kind of alias functions marked as inline because it's an easy save, right? It's an easy win, even if the win is very marginal.
Well, if you get someone who knows the compiler as a guest, then maybe they can explain to you if there is an optimization that'll make that go away anyway.
We can ask Roman on day 8, but I think the last time I asked him when we were talking about inline classes, his answer was usually most likely the JVM is gonna be more clever than whatever you're trying to hint it to in regards to which part it decides to inline or compile to machine code or hotspot, these kind of things. But yeah, well, maybe it's a good idea to ask him again. Okay, so Maya, thoughts on my solution?
I like it. I like it that we thought of doing the score in exactly the same way. I like the fact that you have those nice extension functions that simplifies what that reads. A intersect B intersect C is very readable for me. Of course, chunked. I mean, our solutions are so similar. I think yours is a little bit shorter than mine because mine has an extra flat map in. So yeah, what else can I say? There's one thing that I was thinking about. I mean, we only have 300 backpacks, so it's not the biggest deal.
Mm-hmm.
But maybe there would be a way, like if there were, as I said, if there were hordes of elves covering the jungle, millions and millions of elves, if maybe we would need some other optimizations or how that would work. Someone's asking things. You don't need to intersect all symbols. It is enough to find only first symbol like.
That is actually true. You don't necessarily, you really just need to find the first item. That's a good and cheap optimization. Instead of going for sets, we can always just say, give me the first item that's also in B and in C. If you can have that, that's of course another one. But honestly, I find it easier to reason over sets, if I'm very honest. Okay. So, and the other answer was perhaps the char priority method could be more defensive and throw an exception if the input is not in range. Also true. Also very valid. We could probably replace this with a when statement. So what we could do instead is write something like, we'll have a when statement and we'll say this in, we could just still do is lowercase. So we can just do is low. Actually, we don't want to do this one because this one probably also contains umlauts. So we'll do this in A through Z. These are the lowercase letters. And then we return the thing we've had before. And when we say this in A through Z, I hope someone gets annoyed by the fact that I keep switching the pronunciation for Z and Z. And at that point, we are actually forced by the compiler to provide a when branch, an else branch, where we can say, check your input, or probably something better than this.
That message is, what do you have in your backpack, right?
Yeah, exactly.
Because it's an elf smuggling another letter in his backpack.
And we can just move this one up here as well, which makes our life a little nicer and a little easier. That is the real question. I mean, if you're smuggling an umlaut, yeah, things are gonna get tricky. Other questions: why is the priority extension value not an expression function? And the answer to that one is personal taste. There's no reason for this not to be like a single expression function. We can do this. That works. I don't like this as much. Personally, I'll be very honest with you. I often find myself having to go back and having to add some like code, and then I don't like restructuring it on a very general basis. You can do it. There's nothing wrong with it. A lot of people do it. You'll find it in the standard library. You're probably not going to find me doing it. For me, single method expression bodies are things that I can literally fit on one line. Then I use them. If it's multiple lines, I usually like having a body. How about you, Maya?
I quite like that equal thing, but there's a command to switch between the two, isn't there, in the IDE? So you could have the equal until you needed to add something and then just switch.
You can convert them pretty quickly. So you can convert to block body and back. That's true. Yeah. One of the things that I'm actually a little bit is, so if you have a bit of a call chain like you have here, and this is mainly the fault of the IDE if we do an auto format like I did in advance. I don't know, like, yeah, this is all one call chain, but it starts here, and then the parentheses end here, and the IDE thinks it's a good place to put the next ones here. I'm not that big of a fan. I suppose this one will probably be fixed if we just indented this one down, but yeah, and I'm a big fan of the body syntax. I also use expressions when it's a single when. Perfectly fine. Not doing anything wrong there. I will defend the fact that this is a matter of taste to the end of my days.
So the benefit of putting the dot map on the next line is you can always sneak a dot also in before it, if ever you need to.
Very, very true. Very true. That of course works.
We missed a question. Sorry for interrupting again. There was one about is letter. There's a thing Pamela asked, isn't there an is letter function for our score?
There is a function called isLetter, I'm pretty sure. But the question is, how is a letter defined? We can have a quick look here. So that forwards to character isLetter, which is uppercase letter, lowercase letter, title case letter. I don't want to know what a title case letter is. Modifier letter or other letter. I feel like I feel like this probably covers a little too much.
The net's too wide.
Yeah, so I'm preferring this, and honestly, this seems like a pretty good syntax for just saying, okay, lowercase alphabet, uppercase alphabet, and you just get the chars generated for you. So there's actually one more thing, of course, that we can still talk about, which is these funny little annotations that you put on your code, because it seems that you have followed kind of the homework exercise that we put on yesterday, or the little hint that we made, which is to add Kotlin X benchmark to your project.
Yeah. So I just read the docs and put it in the Gradle file, and then added these annotations. I did have to do some little bit of juggling because you need the setup method. And you have to have these ones, the methods that you want to benchmark can't take any parameters in, which is why you need the setup method. First I did benchmarks and I couldn't understand why things were so quick, but then I realized it was because I never ever read the input. That's what I did there, yeah.
That's like when you write a test and you forget your assertion and it's all green and you're like, oh, cool, nice. Done for the day.
Yeah, exactly.
Oh, you're testing.
Do you want to try and run it, and we'll see what it says?
Yeah, we can try that. So I'm just running the benchmark Gradle task. I apologize if this is a little too small. I forgot to adjust my resolution before the stream.
So while that runs, let me just tell people what it does. Is you add a library, and then you add a benchmark block into your Gradle file, and then it adds some tasks, some benchmark tasks into your Gradle file. We can
probably open this one as well. This block. Okay, yeah.
So, to be honest with you, I just literally copied this from the example in the repo. There wasn't a lot of time, so I don't know what everything means. I just did a copy paste, and then it ran, and then there's a Gradle task that runs, and then it'll give you some benchmark information that comes out. So. I think this is a micro benchmark, right? It's not like a full system. It's literally just taking one piece of code there where you put the annotations, and then just did the micro benchmark.
Yeah, so it literally just it takes the single function that you have here, which is your it takes these two functions that we have, which is part 1 and part 2, and benchmarks them. And the only thing that it does in advance once, which it doesn't count towards the benchmark, is the setup. So we can see here that you're running at that you can call your part 1 function about 1,200 times per second on my laptop, with StreamYard running and everything else going on. Yeah.
Okay, so the thing you can do now is, if you open the sample text, the sample data. I'll tell you why now, because there's an extra. See if there's an extra new line at the end.
Let's see here. Do you
mean? Sorry, not that one. The data. Yes, that one. Okay. Yes. There's no extra new line at the end. Okay, no problem. So now open the util function where it reads.
So this one's in code with me again. So if you'd like to type it out yourself, I'll just follow you on code with me.
Oh yeah. Just need to add some all you need to do is add some zeros. Hang on a sec. How are we going for time, though, right? How much time do we have?
We don't really have that much of a schedule here. The last ones happen to be an hour long, but if there's a little bit longer, that's also fine. So Robert says, my AOC project doesn't use Gradle, though. It uses the IntelliJ build system, I think. Then I think you're going to have a hard time adding Kotlin X benchmark, because that one makes use of the Gradle plugin for its own configuration and this kind of stuff. I'm not sure if we have an automatic converter for introducing Gradle into your project, but honestly, for a project as easy as AOC that doesn't have like a lot of dependencies, at least I assume it doesn't, if you want to run it with Gradle, you can probably just create a new project using just file new project, and then selecting Kotlin and Gradle here. And if you copy paste your sources into that project, you should get the same like little run buttons and stuff. It should work just fine. And then you can play around with Gradle. But be advised that Gradle's a little bit of a different beast. So yeah. Anyway, okay. Back to you, Maya.
So the way I changed this method to read the input is I added this, it reads the whole text, and then there's this repeat line here. And if we just like make the elves multiply 1,000, how many do we want?
Sure, 1,000 times sounds good. So this is like 300,000 then lines.
300,000, yes, that's exactly. And then it splits it back out into lines. So this will just like, it won't get the right answer for your Advent of Code puzzle, but it's just like clones, elf clones.
Yeah. So shall we try running this one?
Okay.
We can see. And you're just gonna see that you're gonna get some different results here.
So what are we expecting? Are we expecting it to be like 1,000 times more?
Yeah, well, we're expecting the operations to be significantly lower, but we can see. So yeah, now we're at 0.72 ops per second, which is I think still a little faster, if I don't have it backwards, than our original invocation. And then for the second part, it's well, you can only call this essentially once every 1 over 0.72 seconds, so 1 over 0.72, so every 1.4 seconds is essentially what we get as our mean execution time. Now, I think that there's also a different output format, but I'm not sure how we're gonna get to that one in your project, which gives a little bit... Oh, never mind, sorry. This is just because we're running a single iteration. If you want to see like how warm-up and stuff affects things, or you just want to run multiple iterations of your code, yeah, you can just change that up here in the measurements. You can also give a time limit and do all these kind of things. It's a full micro benchmark framework, which you can explore on your own time. Again, this is Kotlin X, not benchmark. It's benchmark. Which you can, of course, find on the official Kotlin GitHub account. We're also going to put this very briefly in the chat so you can find it. Right. Yeah. Would you say it was hard to set up the benchmarking process?
No, I mean, the examples were pretty clear. I think the first time around, though, I looked at the Kotlin sample and then the Gradle wasn't groovy.
Mm-hmm.
The Gradle file wasn't groovy. And then I started doing some groovy to Kotlin script conversions. And then I thought, no, I'm not going to do this now. And then I saw that there was actually an example with Kotlin script. So when I put that in, it was easy. And then it did give me some really weird errors when these part 1 and part 2 still had parameters in them. Like unexpected errors, and it points you to some other underlying benchmarking tool, which
the
something at
JMH
state. Yes.
problem.
So then I thought again, oh no, this is not going to work. And then I typed that into Google and I got a Stack Overflow, which said something about parameters. And then I looked back at the example, and then if I just followed the example in the first place, I would have gotten it right.
Okay. All right. So good to know, but with a little bit of setup, you can benchmark your code. Did you actually try any variations, like adding a variation that has a sequence, for example, instead of reallocating at these 2 steps?
No, I didn't. But I mean, like, where do you think we should be? Where could one change? Do you think we should change this input to a sequence? Where would you change it to a sequence?
I mean, we could change this one just to a sequence right away. But
we need to just write down what our answers were, Seb, because we're not going to remember what the answers were for the previous benchmark.
That's very true. The other problem, of course, is that if we wanted to do this properly, we would probably want to have both of these next to each other. So I hope that I can... So these are auto-detected just by... so let's say this one is part 1 sec. Are these auto-detected by the framework as long as they're annotated with benchmark?
Yeah, I saw when it was failing with those errors, it uses reflection.
Okay.
And
understood.
and I think it looks for the annotations, yeah.
So now in this case, we have one variation where we turn everything into sequences first, and the second one not turning everything into sequences and probably allocating a little bit more. And I guess we can run this one and see if we're getting any insightful information about this. Now, of course, if you maybe remember, this is one of the big discussion points in the Kotlin community always, is should I just add as sequence always? The answer is it depends. Especially for small collections, like a quick allocation might be less overhead than creating a sequence object and then iterating over that throughout your call chain. But if you have large collections where you're eliminating elements, that's where sequences begin to shine. Now, of course, elimination we're not doing so directly here with our invocations, but there might be, you know, other parts coming up in the future where this boost might actually help quite a lot. So it's still benchmarking part 2, but we can take a look at the difference between part 1. So the regular part 1, we can, now that we're doing multiple iterations, we can kind of see the average with like confidence intervals and all these kind of fancy things, which is, I guess we're seeing on average 4.58 operations per second. And then for the sequence ones, we're seeing 3.36 operations per second. So in this case, it seems that sequences are actually a whole lot slower than just having the copy, which might be exactly what I said in advance, where short things might get quicker if you can have if you can avoid the overhead of allocating sequence objects and just allocate the very fast like primitives that are already on the JVM pretty baked in. But yeah, the answer to this one is actually always just benchmark and see what the result is. Does this one surprise you? It surprises me, to be honest.
I've got another question. Mm-hmm. Can you see what the memory use is?
That's an excellent question. We can scroll down here, but I don't think that's covered. For that, we would probably have to run with a profiler, I guess, which, or just running it with coverage, which unfortunately I don't think I have set up on this machine. I'm gonna have to.
Because I'm thinking the other thing that a sequence is, because a sequence is lazy, right?
Sure.
So if you think about the memory allocation, if that first, if you can change the way that it reads the input into some other kind of streamed reading, and then have a sequence from that, then have the sequence read the pieces as it needs it, then maybe if you're in a memory constrained environment, that might help. But you'd need to profile that again as well to know if that's any use at all. Not something we're going to code up now.
Yeah, for sure. But it's, I think it's just kind of nice to see also what the setup would look like if you had multiple variations, or if you iterated on your part 1 and part 2 solutions. You can start new iterations or new variations and annotate them with app benchmark. And then if you run all of them at the end, you're going to get an overview of which one of them actually happens to be the fastest, and you don't have to do any kind of guesswork, which is especially cool if you're deciding or talking about things like asymptotic, that's the wrong word. You can tell it's been a pandemic for too long. For asymptotic complexity, whether it actually matters for the size of input that you have, which algorithm you choose, or whether there's something that's maybe faster, even though its runtime complexity is higher. Kind of just is a good way of checking all of this out. So yeah, Kotlin X benchmark. Man, we've really seen a lot today. I'm always so excited because when you look at the puzzles, and even when you look at the solutions, right, they're not that long. It's like 50 lines of code, but there's always so much to discuss. There's always they're chock full of new learnings.
Yeah, no, they're fascinating, and they're a good way. Also, like discussing it like this is a good way to check my own assumptions. Like that thing about the conversion to the char array that could just be a to set. I mean, that's always great. That's always wonderful when I read other people's solutions, or like this when I have a discussion.
Yeah.
With other people doing the.
When we were talking like before the stream, you also mentioned that kind of the psychology aspect of all of this, right? That us humans are essentially pattern recognition machines, right?
Yeah, and so there's an interesting concept. I see the screen is standing on the input chunked. Now there's a term in like the way our brains work, which is called chunking, but it means something different. It means that if you're trying to remember something in your working memory, so when I'm trying to solve this puzzle, I've got like a working memory of maybe 4. Sometimes I think I've only got 3 or 2. That's like the pieces of things that I can fit into my head in any one time, which is often why I kind of break the problems down into pieces so that I can just think about one thing and I don't have to worry about the priority or the score or the other things. I can think about that later. And so the chunking is when your brain actually swaps in like a single thing instead of a whole group of things, and that's how you can keep the 4 pieces into your brain. And so I read a recent research paper that said that chunking works if the chunks themselves don't have overlapping items.
Oh.
Which is just like these little rucksacks, right? It's like these rucksacks with overlapping items. So our memory has these compartments like these rucksacks from these elves, and there's like overlapping, and that's in a way why if you have, say, an object that has more than one responsibility, or you've got a function that has more than one responsibility, you can't chunk it anymore into your working memory. The thing is just like the only thing that this function does is figure out the score for the thing that's in the rucksack, then that's easy. Then when you see it, you don't have to worry about it. But if inside that function it was like changing some other variable in another place and having a lot of side effects, then in a way it makes it more difficult to put those concepts into your brain and work with them in one time.
Which is fun because it perfectly aligns even with the Kotlin vocabulary, right? Because if you compare chunked and windowed functions, the chunked function is gonna be the one that actually gives you non-overlapping groups of your input collection, and the windowed one gives you the sliding window. Yeah.
So it's like poetry, right?
It all fits together. Isn't that delightful?
Yeah, no, that just means that the people that named the methods thought carefully and chose a good one for that one.
Yeah. Okay, wonderful. I think we've exhausted day 3. I hope that everyone who's solved it today, or everyone who tuned in and enjoyed this part of Advent of Code 2022 in Kotlin, either learned something new, or saw a different approach, or looked at my solution and said, my solution is way better, which are all very fair points. So yeah, I'm very glad that all of you have tuned in. Make sure, if you are continuing Advent of Code, to add yourself to one private leaderboard. And if you haven't had enough of Advent of Code content yet, make sure you also check out the links that are in the description, as well as the flashbang alert. It always comes too late. As well as our blog post about taking part in Advent of Code. Because no matter if you're doing it early in the morning or if you're doing it whenever you want, as long as you're in one of the leaderboards, there's a chance for you to win exclusive Advent of Code 2022 swag specific for Kotlin. And you probably don't want to miss out on that. Okay. Well, it's been absolutely lovely having you on the show, Maya. Where can people find you if they want to hear more from you?
So my Deadbird Twitter handle is on the screen. That channel's more for announcements, but I'm also on Mastodon, the same. If you just look for Maya today on the internet, you're going to find either my website with all my links.
All right. So...
Or... yeah, it's all there.
Wonderful. The magic of Google, right? Cool. So, any predictions for the next couple of days about what we're going to see in Advent of Code? Besides, we never know.
A traveling salesman might come past in the jungle, trying to sell us trinkets. Who knows?
Oh, that would be
Dijkstra. Isn't there a Dijkstra thing that might be?
There's usually some kind of graph theory stuff coming up. Yeah, I'm still waiting for one that's mostly like validation of like input, like making sure it fits some kind of format.
Regex. Definitely might be some regex. And then here's a cool tip. if you need to do recursion in Kotlin, you can use that tailrec keyword, right?
That's right. So for
but you have to have the last thing in the method needs to be the method itself, right?
Yes. So that's exactly. So tailrec allows you to specify a function that is, well, tail recursive. So at the end, you're exactly just allowed to call yourself or return some kind of value. You're not allowed to call yourself in the middle, which sometimes kind of throws a wrench in the gears, I think. That's sometimes a little bit troublesome. But the cool thing is that when it is a proper tailrec function, Kotlin can unroll it into just a loop, right? Which makes it even more performant. No more call stacks, no more overflows, because you're not gonna have to allocate all the middle ones because you're tail recursive.
Yeah, I think it's like a while true, and then it just breaks out in the middle when it needs to.
Pretty much. Maybe we can actually, if there's a function or if we're coming up to a problem where a tail recursive solution can be easily created, maybe we'll show that on stream as well. And we are going to, I think that would also be a great time to look at the decompiled output of what the JVM actually ends up executing. So make sure all of you are not gonna miss tomorrow's Advent of Code stream. It's gonna happen the same time as today, and we are going to have another mystery guest, which I'm sure is gonna be very exciting. There's a lot of cool people coming up, so make sure you stay tuned. Okay, I've said it before, but again, thank you so much, Maya, for coming on. I've had a great time.
My pleasure. Yeah, I had a fantastic time.
Wonderful. Okay, then to everyone out there, thanks for tuning in, and hopefully see you tomorrow. Take care. Bye-bye.